Hello and welcome to this almost final tutorial of the part 1 data preprocessing. I look forward to being well prepared with our data to start making our machine learning models. It's going to be very fun. We just have to hold on for 2 more tutorials and then we're good to go. Okay, so today we're going to talk about feature scaling, which is very important in machine learning. I'm going to explain you why right now. So I'm going to go to Google Sheets to find our data set, and here it is. Let's explain what is feature scaling and why we need to do it. Okay, so as you can see, we have these 2 columns, age and salary, that contain numerical numbers. Let's just focus on the age and the salary. You notice that the variables are not on the same scale because the age are going from 27 to 50 and the salary is going from 40k to like 90k. So because this age variable and the salary variable don't have the same scale, this will cause some issues in your machine learning models. And why is that? It's because your machine learning models, a lot of machine learning models, are based on what is called the Euclidean distance. If you remember that back from high school, the Euclidean distance between 2 data points, between 2 points, is the square root of the sum of the squared coordinates. Well, actually here it's the same. We have 2 variables, age and salary. So you can picture age as the x coordinate and the salary as the y coordinate. And in the machine learning models equations, some Euclidean distances between observation points, for example this one and this one, are computed based on these 2 coordinates. And actually, since the salary has a much wider range of values, because it's going from 0 to 100k, the Euclidean distance will be dominated by the salary. Because, for example, if we take 2 observations, for example, this one, the 9th one, and the 3rd one. Well, the Euclidean distance will compute the difference between this salary and this salary. So let's compute it. That's about, okay, so this minus this one. As you can see, this is 31,000. If you put that in square, okay, let's see, up, square, that gives this. And now let's take for the same 2 observations, the ages. So let's compute, equals 48 minus, it was this one, right? 27. Okay, that's the difference. And now let's take the square, equals this square, 441. So you can see very clearly how this square difference dominates this square difference. And that's because these 2 variables are not on the same scale. So, you know, in the machine learning equations, it will be like this doesn't exist because it will be dominated by this. So that's why we absolutely need to put the variables on the same scale. That is that we're going to transform these 2 variables and they're going to have values in the same range. For example, they're going to have values from -1 to +1 here, and same here, -1 to +1, so that we don't get this sort of problem with a huge number here dominating a smaller number here, so that eventually the smaller number doesn't exist. There are several ways of scaling your data. A very common one is the standardization, which means that for each observation and each feature, you withdraw the mean value of all the values of the feature, and you divide it by the standard deviation. So that's the first type of feature scaling, and another type is normalization, which means that you subtract your observation feature x by the minimum value of all the feature values, and you divide it by the difference between the maximum of your feature values and the minimum of your feature values. Don't worry if you're not very comfortable with the mathematics here, but what you need to understand is that we are putting our variables in the same range, in the same scale, so that no variable is dominated by the other. Okay, so let's do it right now. Anyway, you're going to see how the variables are going to be transformed. You're going to see how they go from having large and very different values to small and same values. We're going to see that right now in Python and R. So let's do it. Let's start with Python as usual. Here we are in Python. The feature scaling section is ready with the comment feature scaling. So let's start right now. So as usual, we're going to import a library to do this. And we know this library, we already saw it. It's the preprocessing library. And from this library, we're going to import the standard scalar class. So let's do it. We're going to import sklearn.preprocessing. So that's the preprocessing library. Import standard scalar. All right, so that's the class we need to import. Then, as usual, we're going to create an object of this class, and we're going to call it sc for scale underscore x, because you will see later that we might need to create another object that will scale the dependent variable vector, but so far we will only need to scale the x matrix of features. So scx, and then here standard scalar, which is a class, right? And parenthesis, okay. And now, very simply, we will directly fit and transform our training set and our test set. So let's do this. We're going to transform xtrain, so we will recompute xtrain because we want it to be scaled. And so to do this, we're taking our object sc underscore x, and then we're calling the method fit and transform. So that's very important to understand that. When you are applying your object, standard scalar object, to your training set, you have to fit the object to the training set and then transform it. And you're going to see that it's not going to be the same thing for the test set because we will only transform the test set, but for the training set, we need to fit it and then transform the training set. So, okay, so here we will just need to add as an argument xtrain, and that's it. And now, same for the test set. So we are going to copy this line, paste it here, and here, test. And then xtest here as well. And now, as I just said, for the test set, we don't need to fit the scx object to the test set because it's already fitted to the training set. So here I will remove fit, and we're good to go. Okay, now there are two questions that we can ask ourselves. The first one is really important, and you will find a lot of these questions on Google. This question is, do we need to fit and transform the dummy variables? Because as you can see, dummy variables, okay, let's change the format here for a second. 0, okay. As you can see, the dummy variables takes values either 0 or 1. So do we need to scale that? Because it seems to be already scaled, right? So if you ask this question to Google, you will find several answers. You will find several teams for that. Some will say that no, you don't need to scale these dummy variables. Some say that yes, you need to do it because you want some accuracy in your predictions. And if you're interested in my opinion, I would say that it depends on the context. It depends on how much you want to keep interpretation in your models. Because if we scale this, it will be good because everything will be on the same scale. We will be happy with that, and it will be good for our predictions. But we will lose the interpretation of knowing which observation belongs to which country, etc. So it's as you want. It won't break your model if you don't scale the dummy variables because they will be actually on the same scale as the future scaled variables here, which will take values between -1 and 1, I think. We will see. But here, since this is our final tutorial and we won't have any interpretation to make, we will scale those dummy variables. Alright, so that's how you feature scale. Now let's not forget to select this and Command and Control plus Enter to execute. And here we go. Okay, so now let's check our xtrain and xtest. Let's double click on xtrain. Okay, here's xtrain. As you can see, all the variables now belong to the same range, to the same scale. As you can see, all the variables seems to be between -1 and +1. So that's perfect. That will largely improve your machine learning models. And besides, I forgot to mention that even if sometimes machine learning models are not based on Euclidean distances, we will still need to do feature scaling because the algorithm will converge much faster. That will be the case for decision trees. Decision trees are not based on Euclidean distances, but you will see that we will need to do feature scaling because if we don't do it, they will run for a very long time. Okay, and let's have a quick look at xtest. That's xtest. It's also feature scaled. And you have to understand that the feature scaling here in xtest is the same as the feature scaling on xtrain, simply because the object standard scalar was fitted to xtrain. That's why it's important to fit the object to xtrain first, so that xtrain and xtest are scaled on the same basis. Okay, and now I promised you another question. The other question was, do we need to apply feature scaling to y, the dependent variable vector, so to ytrain and ytest? Here, as you can see, the dependent variable vector is a categorical variable because it's taking only two values, 0 and 1. And now the question is, do we need to apply feature scaling on this one? Well, the answer is no this time. We don't need to apply feature scaling to this one. However, here we don't need to do it because this is a classification problem with a categorical dependent variable, but you will see that for regression, when the dependent variable will take a huge range of values, we will need to apply feature scaling to the dependent variable y as well. But let's not worry about that for now. You will see how we will do it in the regression section. And actually you will see that it's very simple. We will just be doing the same thing as we did for X train and X test. Okay, so that's good for Python. Congratulations. Now you master feature scaling in Python. So let's move on to R. So here we are in R. And now that you understand feature scaling, let's apply it to the training set and the test set. Here we will just write 2 lines of code, which are, so the first line is training set. So the training set already exists, right? It's this one, the training set. As you can see, it's not scaled. It contains the raw values. So training set equals, and simply now we're going to write scale, and then training set. That's all. That scales your training set. Isn't it great? And same for the test set. We will copy this line, paste it here, and we will change training into test, and here as well. Okay, so here I just wrote this. There is something important to understand. This will be the feature scaling block of code that we will be using in our template. However, let's see what happens when I select this code and execute it. So let's select this, execute. Okay, as you can see here, I obtained 2 errors. Error and call means X must be numeric for the training set and the test set. Can you guess what the problem is? The problem is that, okay, well, it tells us what the problem is. It tells us that X must be numeric. But what does that mean? Well, first, what is this X? X is, for this line of code, the training set, and for this line of code, the test set. So let's forget the test set for a second and let's focus on the training set. So X is a training set and it says that the training set must be numeric. So let's look at our training set. Okay, well, the training set looks numeric, right? Here we have numeric values, numeric values, numeric values, numeric values. But no, actually, there are 2 columns that don't have numeric values. It's this one, the country, and this one, purchased. And do you remember why? Well, it's because before we had the country written in text and the purchase column written in text with yes or no, and we changed that by putting the categories as factors. That's what we did here, as you remember. Dataset country equals factor of the different levels and labels. And a factor in R is not a numeric number. And when you apply the scale here, X must be numeric. That means that all the columns in X, that is the training set, must be numeric. So this time we're going to exclude the categories from the feature scaling. We're not going to apply feature scaling on those columns. So that's very simple. All we need to do is to take the columns we're interested in, which are, well, the indexes of the column we want to scale, which are indexes. So indexes in R start at 1, so that's 1, 2, 3. So that's the second and third index we want to take to scale the age and the salary columns. So 2 and 3, let's input it. We need to specify here 2 colon 3, and that gets what we want. So now I'm going to copy this, copy, paste it here, here, and here. All right, and now it's ready. Let's have a look at the training set and the test set. So not scaled, not scaled. Let's go back to our code. Let's select this, and now we shouldn't get an error. Command and Control + Enter to execute. Here we go. It executed properly. And now let's look at the training set. All scaled properly, perfect. And the test set, all scaled properly. Perfect, and now our data is ready to offer a good precision, a good accuracy, and a fast work of the machine learning models. And by that I mean that the machine learning models will converge rapidly. Okay, so that's it for feature scaling. Now you know how to apply feature scaling to your data in Python and R. congratulations, and mostly congratulations because we did all the required steps to pre-process our data. Feature scaling was the last one because the next tutorial will be about this data preprocessing template, and I will just explain how we are going to use it in our machine learning models. It's going to be very fast and practical. So we are done with the data preprocessing. Congratulations, you did the most difficult part, and now it's time to have fun. It's time to start making the models, and I can't wait to start them with you. So thank you for watching this tutorial. I look forward to seeing you on the next one, and until then, enjoy machine learning.